Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 23, the defining equation of a line. Exploratory challenge exercises 1 through 3 are just that. They're exercises. Get to work, see if you can do it, pause the video, and I will show you the results. So here's number 1. Check the graph of the equation 9x plus 3y equals 18 using intercepts. Okay, there we go. We want to use intercepts. Now remember, if I have a graph, and this is the x-axis and this is the y-axis, and I have a line that crosses both of them, then the y-intercept is here, and the x-intercept is here. Well, if it is an x-intercept, this would be a point, if that were, say, 2, then this would be the point 2, 0. 2, 0. And if this were on the y-axis, let's say that's -1, -2, then this would be the point 0, -2. So when we are on the x-axis, y is 0. When we're on the y-axis, x is 0. So until you get the hang of this, I'm going to write that. I'm going to write y-intercept here, and I'm going to write x-intercept here. And what I need to know in the y-intercept is that x equals 0. And when I'm looking on the x-intercept, I know that y equals 0. And then I'm going to solve this equation with this information. So if I take that 9x plus 3y equals 18, and x is 0, this is 9 times 0 plus 3y equals 18. 0 plus 3y equals 18, and 3y equals, that's a scary y, 3y equals 18, divide both sides by 3, and y equals 6. So it is the point 0, 6. Okay, x-intercept, the y is 0. Take that same equation, 9x plus 3y equals 18. Substitute in the 0 for the y. So it's 9x plus 0. 3 times 0 is 18. So 9x equals 18. Divide both sides by 9. These cancel. X equals 2. So that means that x is 2, then y has to be 0. So there are our 2 points. Now I'm going to graph them. Sketch the graph of the equation, then answer parts A through F that follows. Okay, so I opened up my Geogebra graphing calculator, and I'm going to just plot these points, 0, 6, and 2, 0. So 0, 6 is off the chart right now, so if I just move this down, you'll see it. 0, 6 is right there, or I can zoom out. Okay, so there is the point 0, 6. Now I plot the point 2, 0. So if I input 2, 0, there is my y-intercept. So if did I say y-intercept? This is my x-intercept. This is my y-intercept. And now I can graph a line through those 2 points. And there it is. Okay. And there's my equation. Y equals -3x plus 6. Okay, so it put it in standard, or this is standard form. It put it in slope-intercept form for us. Okay, interesting. So now I'm going to zoom out a little bit, and as you can see, that is just a straight line going through those 2 points, 0, 6, 2, 0. Okay. So now it says to sketch the graph of the equation y equals -3x plus 6. Okay, so if I go back to Geogebra like I had out, bring that back in, y equals -3x plus 6 is right here, and if I put in 9x plus 3y equals 18, then you don't see it. And the reason is it's behind Now it turned green when I clicked in here. So if I click on F, F and G are my two functions. One's in gray or black, and this one's green. As you can see, they're on the same line. So negative 3x plus 6 is the same as 9x plus 3y equals 18. Okay. So there's both of them sketched, F and G. Okay, they coincide. B, what do you notice about the two graphs? Okay. What do you notice about the graphs of negative, or 9x plus 3y equals 18 and y equals negative 3x plus 6? And you would say the graphs are the same. Because substituting in the two intercepts make each equation true. Okay. So that's just those are just my words. The graphs are the same because substituting the two intercepts make the equations true. So if I plug in 0, 6 here, I get 0 plus 6 is 6. That's true. And if I plug in 0, 6 here, that'd be 9 times 0 is 0, and 3 times 6 is 18. 0 plus 18 equals 18, so that is true. Use 2 and 0. Negative 3 times 2 is negative 6, plus 6 is 0. Negative 6 plus 6 equals 0. That is true. And if I make 9 2 or x2, then 9 times 2 is 18, plus 3 times 0 is 18, and that is also true. C says to rewrite y equals negative 3x plus 6 in standard form. So in order to do that, we want ax plus by equals c. And in order to do that, I need to move my x out in front. So I need to add 3x to both sides. When I do that, I get 3x plus y equals negative 3 plus 3x equals 0, plus 6 is 6. So I have 3x plus y equals 6. And that is in standard form. A is positive, and there's no fractions. D says, identify the constants A, B, and C of the equation in standard form from part C. A is my coefficient of x, so that is 3. B is my coefficient of y, which is 1, and C is my constant on the other side, which is 6. Okay, so I answered D. E says identify the constants of the equation 9x plus 3y equals 18. Well, A prime is, they're calling us to note them as A prime, B prime, and C prime. A prime is 9. B prime is the coefficient of y, which is 3. And C prime is the constant 18. What do you notice about A prime, B prime, C prime over A prime, B prime, or A, B, C? Okay, what are they asking here? What do you notice about A prime over A, comma, okay, B prime over B, comma, and C prime over C. Okay, so I'm going to set these up. A prime is 9 over A, which I'll get on the other page after. B prime is 3, and C prime is 18. So if I'm going to set these ratios up, then I need to go back, and A was 3, B was 1, and C was 6. So 3, 1, 6. Okay, so it says, what do you notice about A prime over A, B prime over B, and C prime over C? Well, 9 divided by 3 is 3, 3 divided by 1 is 3, 18 divided by 6 is 3. So the top is a multiple of 3. So they're the same equation, just multiplied by 3. Okay, so number 2, it says, sketch the graph of the equation y equals 1/2 x plus 3 using the y-intercept point and the slope. Then answer parts A through F. I'm not going to use Geogebra for this one. I'm going to just use a piece of graph paper. Okay, so I brought in a grid, coordinate plane, and a ruler. That's what you need to graph. Graph paper and a straight edge, and my magic pencil. Sketch the graph of the equation y equals 1/2 x plus 3 using the y-intercept point and the slope. Okay, so my y-intercept, which is b, equals 3. That's right here. And my slope equals 1/2, which means rise 2, run 1. So I plot my 3 first, 1, 2, 3. So this is b equals 3, or 3 comma, or 0 comma 3. And then it says to go up 1, right 2. So I go up 1, right 2, and I put a point there. Now I'm going to bring my ruler up and draw a nice, accurate straight line with the ruler. Okay, so there's my line, and I'll label that y equals 1/2 x plus 3. So there's the graph of the line y equals 1/2 x plus 3. Actually, that's not right. Okay. Hang on one sec. My slope is off. I plotted my second point wrong, so I need to fix that. I counted up 2 over 2. Up 1 over 2 is here. All right, I saw that after. My apologies. So up 1 over 2 is up 1 over 2, up 1 over 2. And this is why you should do your homework in pencil, or your notes in pencil. Math should always be done in pencil, so you can fix corrections without starting over on a separate sheet of paper or scribbling out. So there's my equation graphed, and that is y equals 1/2 x plus 3. Now it says, sketch the graph of the equation 4x minus 8y equals negative 24 using intercepts on the same coordinate plane. So if I have 4x minus 8 equals negative 24, and I want to find the y-intercept, then I let x equals 0. That's the rule. So I'm going to say 4 times 0 minus 8 equals negative 24. So that's 0, so negative 8 equals, oops, I forgot my y. Forgot my y. Negative 8y equals negative 24. Divide by negative 8. Those cancel. Divide by negative 8. And y equals 3. Negative divided by negative is positive. 24 divided by 8 is 3. So when x is 0, y is 3. So I go over here. 0, 3 is right here. Then I do x intercept. That means y equals 0. There's our rule. So 4x minus 8y equals negative 24. And I'm going to let y equal 0. So it's 4x minus 8 times 0 equals negative 24. And 4x minus 0 is just simply 4x equals negative 24. Divide both sides by 4. And x equals negative 6. So I have the point negative 6, comma 0. So I go over 1, 2, 3, 4, 5, 6. It is right here. And this was my y-intercept. So it says, what do you notice about the graphs of y equals 1/2 x plus 3 and 4x minus 8y equals negative 24? Well, if you notice, we only need 2 points to graph a line. And if I drew a line through these 2 points here that are in black, I would get that purple line again. So rather than doing that, well, I suppose I should, if I just bring my ruler over here and draw a line through there, like so, then you see that they're the same line. Okay. B says, what do you notice about the graphs of y equals 1/2 x plus 3 and 4x minus 8y equals negative 24? Well, they graph the same line. Okay. I'm just going to say this because I've said it in the last one. they graph the same line. The line that was graphed for both of them are coinciding lines. And this point 0,3 makes both equations true, and the point -6,0 makes both equations true. So basically these two equations are the same. So now it's asking us to rewrite y equals 1/2 x plus 3 in standard form, and we need to move this x out in front, so it says ax plus by equals c. So I'm going to subtract 1/2 x from both sides. So I have 1/2 x negative 1/2 x plus y equals 1/2 x minus 1/2 x is 0 plus 3, or simply 3. So I have this ax plus by equals c, but a is negative and there is a fraction in here, so I don't want either. So I'm going to multiply by a negative, and the denominator will get rid of my fraction, so I'm going to multiply by -2. Negative times negative is positive. 2 times 1/2 is 1, leaving me with x plus -2 times y is -2y, and we're beyond that plus or minus stuff from last year, so we're just going to say minus 2y equals -2 times 3, which is -6. So there is the equation in standard form. Okay, now it says to identify the constants a, b, and c in the equation in standard form in part C. So part C says that a is 1, b is -2, and c is -6. So a equals 1, b equals -2, and c equals -6. Now it says to identify the constants in this equation, noting that they are a prime, b prime, and c prime. So a prime is the coefficient of the variable x, which is 4. B prime is the variable coefficient of y, or the coefficient of the variable y, which is -8. And c prime is the constant, which is -24. Okay, so now it wants us to put these in as ratios. So a prime is 4 over a, which was 1. B prime is -8 over b, which is -2. And c prime is -24, where c is -6. So 4 divided by 1 is 4, -8 divided by -2 is 4, and -24 divided by 6 is 4. So these two equations are equivalent. This one is just a multiple of 4 of the original equation. Okay, so if we scale a line by 4, then the points just spread out, and it's still the same line. Okay, number 3. Number 3 says the graphs of the equation y equals 2/3 x minus 4 and 6x minus 9y equals 36 are the same line. This is slope-intercept form. This is standard form. It says to rewrite the slope-intercept form in standard form, so I need to move this 2/3 x out in front by subtracting 2/3. And actually, I didn't like the way that last problem looked by not rewriting the problem, so I'm going to start by rewriting y equals 2 over 3x minus 4. I need this over here, so I subtract 2/3 x from both sides. When I do that, I get 0 minus 2/3 x, which is -2/3 x. That's a positive y plus y equals, these are 0 minus 4 is -4. A cannot be negative, a cannot be a fraction, so I multiply by a negative to get rid of that negative, and I multiply by the denominator to get rid of the fraction. So negative times a negative is positive, the 3's cancel, and I get 2x. -3 times y is -3y. Negative times a negative is positive, 3 times 4 is 12. Now it's asking me to identify the constants a, b, and c in that standard form. So a equals 2. B is the coefficient of y, -3. And c is the constant 12. And then here, they're asking us to do the same thing. What is the constant of this? Identify the constants of the equation 6x minus 9y equals 36. Okay, so constants of the equation. I don't call those constants. They are, but they're coefficients. So a prime is the coefficient of x, which is 6. B prime is the coefficient of y, which is negative 9. And C prime is the coefficient, or the constant, 36. So then it says to put a prime over a, which is 6 over 2. B prime, negative 9, over b, negative 3. And C prime, 36, right here, over c, which is 12. 6 divided by 2 is 3. Negative divided by negative is positive. 9 divided by 3 is 3. 36 divided by 12 is 3. So what do we notice about those two? The second one is a multiple of 3 of the same equation. E, you should have noticed that each fraction was equal to the same constant. Multiply that constant by the standard form of the equation from part A, and what do you notice? So what they're saying is, if we go back up to part A, and take this standard form right here and multiply it by 3. So 2x minus 3y equals 12. So I'm going to copy that. And we're going to multiply it by this 3 that we came up with. So if I go back to this problem here and put it here, and take this equation and multiply it by 3, then 3 times 2x is 6x. 3 times a negative 3y is negative 9y. And 3 times 12, why is there a 3 over here too? Shouldn't be. 3 times 12 is 36. So I get 6x minus 9y equals 36. And if I come back here, I have 6x minus 9y equals 36. So it's a multiple of 3. Okay, exercise 4. Write 3 equations whose graphs are the same line as the equation 3x plus 2y equals 7. All right, try that, pause the video, and then unpause it, and we'll see how you did. So as we learned from this problem up above here, if we just multiply everything by the same number, the two equations will graph out to be the same. The same x's and y's will make each equation true. They are the same equation. So if I want to write equations whose graph have the same line, then I'm going to find a scale multiple, and let's not make it difficult. Let's just start with 2. And if I multiply 2 times 3x plus 2y equals 7, and distribute everything through, 2 times 3x is 6x, 2 times 2y is 4y, and 2 times 7 is 14. So 6x plus 4y equals 14 would be the same equation as this. Okay, and it says to do 3 times, so now I'm going to choose, how about a negative number now? Negative 3 times 3x plus 2y equals 7. And then when I distribute, negative 3 times 3 is negative 9x. Negative 3 times a positive 2 is negative 6y. Negative 3 times 7 equals negative 21. Okay, and then I'm going to do that again. 3x plus 2y equals 7. Multiplied by some scale multiple. How about 10 this time? 10 times 3x is 30x. 10 times 2y is 20y. And 10 times 7 is 70. So these 3 equations are equivalent and would give the same results if we plugged in x and y values. They would all be on the same line. Number 5, write the 3 equations whose graphs are the same as this one. Okay, so again, we're just going to, and to save time, here's what I'm going to do. X minus 9y equals 3/4. And I'm going to copy that 3 times. Okay, so I'm going to put this here. I'm going to put this over here. Pick any number to multiply by, other than 1, or 0, of course. So I could do negative 1, 2, and 5. Just making these up. Negative 1 times x is negative x. Ooh, Houston, we have a problem. I don't want a to be negative, so let's not do the negative 1. Let's make this 4. 4 times x is 4x. Minus 4 times 9 is 36y. Equals 4 times 3/4 is 3. Okay. Why did this copy a different one? No idea. Take this. Taste twice. That's strange. Okay. All right, so now I'm going to multiply this by, now that I see that this 4 is here, I don't want fractions. It doesn't really matter. But if I choose multiples of 4, I'll get rid of that fraction. Okay, so that's a little 7th grade trick. 8 times x is 8x. 8 times a negative 9y is negative 72y. And 8 times 3/4 is 6. Because 8 divided by 4 is 2, and 2 times 3 is 6. And then I will do 12. 12 times x is 12x. 12 times negative 9 is negative 36y. And 12 times 3/4 is 9. 12 divided by 4 is 3. 3 times 3 is 9. These three equations are equivalent. Okay, so now they're asking us to do it another time. Write three equations whose graphs are the same line as this equation. Negative 9x plus 5y equals negative 4. We're going to multiply that. So I'm going to copy it 3 times. Okay. And just choose 3 different values to multiply by. Now this time I have a negative a, and I can't have a negative a, so I'm going to choose negative values to multiply this by. And this is what they're trying to get you to do in these problems. If you multiplied by a positive and left your a negative, it is not in standard form. And this one is not in standard form. So I'm going to practice that rule, and I'm going to make this standard form by getting rid of that negative 9. So I'm going to multiply by negative 1, negative 2, and negative 3. So when I multiply these, I get 9x. Negative times a positive is negative 5y. Negative times a negative is positive 4. Okay, so that's distributing. I didn't draw my arrows, but I think you get the idea now. Negative times a negative is positive. 9 times 2 is 18. Negative times a positive is negative. 2 times 5 is 10. Negative times a negative is positive. 2 times 4 is 8. Negative times a negative is positive 27x. Negative times a positive is negative 15y. Negative times a negative is a positive 12. Okay, so there's 3 equations that are equivalent. And they're in standard form now because there's no negative a's or fractions. Number 7 says to write at least 2 equations in the form of ax plus by equals c whose graphs are the lines shown below. Okay, so I do not have an integer for my y-intercept, so I will not use my intercepts to answer this question. But I do have my x-intercept, which is the point 3, 0. And then I'm going to look for another integer, so I have to go over to here. That's not an integer, neither is that, but this one is right on a corner, and that is the point 1, 7. So that means I went up 1 and to the right from 3 to 7, which is a distance of 4. Okay, so I'm going to write this equation as y equals mx plus b. I'm going to do it in slope-intercept form, and then I'm going to convert it. So my slope is up 1 over 4, and my b is, I don't know. It's something between 0 and negative 1, but I'm not sure. So I am going to plug in one of these 2 values. I like 0 because things go away, so I'm going to choose 3, 0. So my x is going to be 3, and my y is going to be 0. So I get 0 equals 3/4 plus b. I want b by itself, so I subtract 3/4 from both sides. and I get 0 minus 3/4 is negative 3/4. Negative, or 3/4 minus 3/4 is 0, and therefore that is my b. So my equation now is y equals my m, which is 1/4, x minus 3/4, my b. So it's a negative 3/4. So that's the point negative 3/4, comma, or 0, comma, negative 3/4. There's my equation in slope-intercept form, but it says to write at least two equations in the form of ax plus by equals c, standard form, whose graphs are in the line shown below. So I need to put this in standard form by moving my x, and that's going to subtract 1/4 x from both sides. And when I do that, I get negative 1/4 x. That's a positive y, so plus y equals 0 minus 3/4, which is a negative 3/4. This is not standard form yet because I can't have fractions and a can't be negative. So I'm going to multiply by a negative 4 to get rid of the fraction. Negative 4 times a negative 1/4 is positive 1x. Negative 4 times y is negative 4y. And negative 4 times a negative 3/4 is positive 3. So there's one equation in the form of ax plus by equals c, whose graph is the line shown. Now I'm just going to take that number, or that line, that equation, and multiply it by something. So I'm going to multiply it by, oh, I don't know, 2. Let's keep it simple. 2 times x is 2x. 2 times negative 4y is negative 8y, and 2 times 3 equals 6. So there are two equations in the form of ax plus by equals c, who are equal, and graph of that line. Okay, number 8 says to do basically the same thing, so try it, pause the video, come back, see how you do. And so I always look at x-intercepts and y-intercepts first. It's just easier if they're integers, but unfortunately neither one is this time. So I just, I don't know, go down the line until I find an integer value, and that is the point 2 comma negative 2. And not an integer, not an integer. No, 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 no. Yes, there's a point. This point is the point negative 1 comma 2. So there are my 2 points that I'm going to use. And I'm going to do this one differently. I'm going to use the slope formula. So I want y equals mx plus b. So instead of just doing rise over run, I want to know what m is. And that's y2 minus y1 divided by x2 minus x1. So this is my first point, reading left to right on the number line. If I'm going this way, this is the first point, and keep going this way, this is the second point. So this is x from the first point, this is y from the first point, this is x from the second point, and this is my y from the second point. And that's where these y2, y1s come from. So y2 minus y1 is y2, negative 2, minus y1, which is 2, over x2, which is 2, minus x1, which is negative 1. Okay, so be careful of that double minus. So my slope is going to be negative 2 minus 2, which is negative 4, and 2 plus 1 is 3. So my slope is negative 4/3. So now I have this equation here, and I have negative 4 over 3 in place of my m. I have x's and y's here, so I'm going to use one of them. I will use this point here to plug into my equation, simply because it's only got one negative, where this, oh, they both do, so it didn't really matter. So my x is negative 1, so I'm going to multiply this by negative 1. Okay, and my y was 2, so I'm going to put a 2 there. And we're trying to find b, so we take our slope times our x, and we get negative times negative is positive 4/3 plus b. Now I see I've got to subtract a fraction from an integer, so I'm going to change that 2 to a fraction with a denominator of 2, and 2 is 6/3. 6 divided by 3 is 2. And now I can subtract 4/3 from both sides. And when I do that, 6 minus 4 is 2/3. These cancel, and we found our b. So now I'm going to take this equation and rewrite it as y equals negative 4/3 x plus 2/3. There is my slope-intercept form of my equation. I need standard form, so I need to move the x over to the other side by adding 4/3 x to both sides. When I do that, I get 4 over 3x plus, it's a positive y, plus y equals, this is 0 plus 2/3. So there's my standard form, but we're not quite done yet because I can't have fractions. I'm going to multiply by the denominator to get rid of them. 3 times 4/3 is 4x. 3 times y is 3y. 3 times 3 cancels, leaving me with 2. So 4x plus 3y equals 2. Write at least 2 equations in the form of ax plus by equals c. Okay, so here's one. And another one would be a multiple of that. So I'm going to multiply this by 2. 2 times 4x is 8x. 2 times 3y is 6y. And 2 times 2 is 4. So my 2 equations are, oh, can't move all that. Don't want to do that. Okay. My 2 equations are 8x plus 6y equals 4 and 4x plus 3y equals 2. Those are my 2 equations. Okay, that is the end of lesson 23. Review the summary and go to your problem set.